Welcome back to the Game Asset Series, Part 2. In Part 1, we delved into the crucial difference between unique and trimmed textures, exploring how to maximize the efficiency of that setup. I also walked you through the modeling process for several key exterior panels, including the wheel well panel, luggage compartment panel, side engine vent panel, door panel, middle panel, and the large panel for the general exterior. Now in this episode, we're going to pick up right where we left off. We'll be focusing on the essential steps of low poly modeling, setting up the UVs, and preparing everything we need to export both the high poly and low poly versions for Substance Painter. Let's jump right into it. I'm a quarter of the way there, having finished almost all of the trim panels. There's still the trim for interior purposes, such as the lower and upper interior walls, floors, and ceiling. And for the exterior, the back part of the bus needs detailed modeling, along with the wheels and tires. So, for the sake of duration, and to keep things concise, and definitely not to bore you with watching nearly an hour of detailed modeling, I've taken the liberty of completing those remaining parts offline. I understand that seeing the process is valuable, but I wanted to respect your time. Now I'll do my absolute best to explain the techniques and considerations that went into creating those interior trim panels and the detailed rear exterior, including the wheels and tires. I'll focus on the key decisions and workflows, highlighting any interesting challenges and solutions I encountered. I'll aim to give you a clear understanding of how I achieved the final result, even without the real-time demonstration. For the seats, I started with a simple box, then applied mirror and subdivision surface modifiers. This allowed me to focus on shaping the seat effectively, working on only one half. I used loop cuts to tighten the edges, making them slightly sharper, and fewer loop cuts in areas where I wanted a rounded appearance. For the piping detail on the seats, I first modeled the base seat as described. Then I duplicated the seat, increased the subdivision surface modifier to level 2, and applied all modifiers. Next, I identified the edge loops that closely matched the desired location of the piping, selected them, and separated them into a new object. I then converted these edge loops to curves and added thickness to create the piping. For the seat metal frame, I started with a plane, shaped it into an L, and applied a solidify modifier to give it thickness. Once it had the desired L shape and thickness, I applied the solidify modifier. To maintain a consistent look with the seat, I copied the subdivision surface modifier from the seat and applied it to the frame. Finally, I added loop cuts to sharpen the edges a bit, while still keeping them rounded enough for good baking results. And for the seat backrest, I actually copied the main seat object. Then, I duplicated that copy using Alt+D, a linked duplicate, and rotated the linked duplicate to a suitable angle for a backrest. After that, I modified the original copied seat object, elongating it and shaping it to resemble a cover over the top part of the backrest. In fact, I created two variations, one backrest with the cover and another without, to add variety to the seats. The piping on the backrest was created using the exact same method as the seat piping, which I described earlier. For the steering wheel, it's a relatively simple setup. I used basic box modeling to create the overall shape, then added a bevel modifier to soften the sharp edges. For the circular part of the wheel, I used a torus, and a cylinder serves as the steering rod. Since the driver's area won't be accessible to the player in the game but needs to be visually present, a high level of detail isn't necessary. The same approach was used for the driver's console. I modeled it from a basic box, shaping it to resemble a console, and then added a bevel modifier for baking purposes. During the modeling process, I focused on creating significant elevation changes across the surface. This was intentional, as these variations will create areas of occlusion, resulting in a good ambient occlusion, AO bake, which will add depth and realism to the console. For the back part of the bus, I used a reference image of another bus that showed the entirety of the rear, allowing me to accurately model the details. I only modeled the engine compartment door panel and one part of the light. For the engine compartment panel, I used a plane and leveraged a mirror modifier. Then I added a bevel modifier and a solidify modifier. Just like when modeling the wheel well panel, I used loop cuts and V to rip the panel loops, which allowed me to add detail to each individual panel. To further enhance the depth and form, I extruded some faces downwards and others upwards, creating a more dynamic surface. For the lines on the lower part of the panel, I used the knife tool to precisely cut the lines into the desired shape. For the backlight part, I started with a simple box and scaled it along the x-axis to achieve the correct height for the rear light. Then, I beveled one edge to create a fully rounded shape. To define the actual light shape, I used the knife tool, or the K shortcut, to cut out the desired form. I then separated the light shape from the main body and added thickness to both pieces by modeling the thickness directly, essentially extruding the faces inwards. Finally, I added a bevel modifier to round things out, ensuring a smoother, more realistic appearance for the light elements. As for this part, I'm using it as a speaker for the interior of the bus. Now I only actually need the two middle ones for the final model. The outer ones are primarily for baking purposes, specifically to ensure the ambient occlusion, AO bake, is balanced on both the right and left sides of the object. Now let's take a look at the trims I'll be using for the interior of the bus. These are essential for adding that extra layer of detail and realism that really brings a scene to life. First up, we have the trim for the interior walls, which will define the edges and paneling, adding a sense of structure. Then we have the top linings for the bus, crucial for creating a clean transition between the ceiling and walls. Following that, we have the window frame trims, which will help to frame the windows and give them a more defined look. We'll also be using the window rubber seal trim to add that subtle detail that makes a big difference in realism. And of course, we have the metal trims for general interior purposes, which will add a touch of sophistication and detail to various surfaces. These trims, and so on, will be strategically placed throughout the interior to create a cohesive and believable environment. By paying attention to these smaller details, we can elevate the overall quality of the asset and make it truly immersive. Before I move on, there's one thing I forgot to model: the license plate for the bus. I'm just going to add a cube, edit it to form the license plate shape, add a bevel modifier to round out the edges, and done! With the license plate finished, we can now move on. This trim will be used as my bus tire tread, and for the tire wall and rims, I'll be using a unique texture derived from this very mesh. Now, because this texture has a seamless tiling pattern, there's a crucial step I need to take before creating the low poly. To ensure that the mesh with the seamless tiling texture bakes correctly, I need to copy it on either side of the original mesh. This ensures that the baked ambient occlusion, AO, and thickness maps are even across the strips. Without this duplication, you risk creating uneven seams on the strip due to imbalanced baking. This step is only crucial for those meshes that will be seamlessly tiled. If the texture isn't seamless, then I don't need to copy the mesh. This trim will be used for the floor and any elements that are less than 1 meter in width, maybe like door trims, step trims, or anything similar. That's why I'm copying it on either side, to prevent visible seams in baking. All of the trims were created using a similar process to the wheel well panel. I started with a plane, moved the origin to a corner vertex, and adjusted the width to 4 meters. The height varied among the panels. The wall panels are 1 meter, and the other strips are adjusted according to my specific needs. After that, I deleted the back and side faces to ensure proper tiling. I'll be time-lapsing it again, like usual. If there's anything that needs further explanation, I'll switch back to normal speed and walk you through it. To create the low poly version of these trim pieces, simply select a representative flat face from the high poly model and create a corresponding plane. Match the size of the plane to the dimensions of the specific trim piece you are working on. This plane will serve as the low poly representation. Apply this low poly plane creation process to all of the trim sheets in your project. Engine door. Duplicate the high poly mesh. Begin simplification by flattening the majority of the surface. Select and merge vertices strategically to reduce polygon count. However, preserve the integrity of the descending notch and the ascending line detail. All other surfaces should be flattened to a single plane. parts that have a unique texture, I duplicate the high poly mesh and lower down the subdivision to level 1 and apply the modifier, essentially making it permanently smooth at level 1. I only need the seat part. For the piping, I can delete it. And start rather simplifying it more by deleting edge loops that are not required to sustain the shape. And select all faces and Alt-S to expand the mesh a bit to envelope the whole high poly mesh. To make it easier for me to delete the edges, select half of the mesh and delete it. I only need one half of this mesh. I can add a mirror to make it whole again. Now I've completed making the low poly versions of the parts with unique textures. I used similar techniques, although some parts only required a bevel modifier. For those parts with a bevel modifier, I simply copied the mesh, deleted the modifier, and then simplified it, just as I did with the seats. And also I grouped them into their own collections to avoid any mishaps. For example, the low poly versions I placed in collections named low, and the high poly versions in collections named high. This organization is crucial, especially when working with complex models. Keeping the high and low poly meshes separate prevents accidental modifications or deletions. It also makes the scene much cleaner and easier to navigate. By using consistent naming conventions and collections, I can quickly find and select the specific meshes I need, saving a lot of time and reducing the risk of errors during the baking process or further editing. And importantly, I also check for normals. I don't want any normals flipped in the high poly or the low poly, because if there are any flipped normals, the baking process will leave quite a few artifacts, which would be a real headache to fix later. Let me divide my workspace vertically so I can create a room for the UV editor. I usually use two monitors. On the first monitor, I like to keep the 3D view fully up, and on the second monitor, I usually keep all the windows regarding tweaking. Select all the tiling trims, press U, and select Unwrap, angle-based. This will unwrap your model. As mentioned in my previous video game asset series, The Red Barrel, I used Mio3 UV, which are free extensions. You can go look for it and install it in your Blender, then what I'm about to explain to you will make sense. If you're having trouble, I recommend checking the Mio3 UV documentation or searching for some tutorials online. There are some great resources available. In the Mio3 UV tab, go to the Display section and below the checkered map, select the output you want to see. I'll go with 4096, which should pop in your mesh. If not, just go to the Viewport Shading option and click on Texture. If for some reason the display only works on one of your meshes, just select all of your other meshes, Shift-select the mesh that has the texture, and then Ctrl+L to select Link Material. That should do it. Now I'm reorienting the UV maps. If there are any maps that are upside down, I'll make them right side up. By using the texture, it's apparent which ones need fixing and which ones don't. And I'll make the trims that are vertical into horizontal trims. This step is very crucial. I recommend doing this stage before packing the UVs because Substance Painter uses physically based effects when it comes to rust drips. Let's say there are unequal orientations of the maps. The ones with vertical orientation will have the drips going sideways instead of top to bottom. Now as for the back engine door compartment, I just added seams at the start of the lines to separate them from the main panel. I tried joining those two earlier, but the result was a mess, creating artifacts in the adjoining parts of the lines and panel. And also, I'm applying the mirror modifier now that I'm done modeling. I'm also applying the same materials as the rest of the panel, so I have a clear view when I unwrap it. The unwrap is not bad, but also not good. I'm taking the manual approach of fixing the vertices to make them align and straight. As for the other uniquely textured meshes, the techniques are the same as you would treat any other mesh, just make seams and unwrap it. I'll time-lapse it here and we'll be back to normal pace if there's something to explain. Now that I have everything set up, the next step is to go to the UV editor window, select UV, and then click Average Island Scale. This will average the scale between meshes based on their size in the 3D world. If, for some reason, you have UV islands of unequal size, you'll need to apply the scale to the mesh with the unequal size. Then, simply click Pack Islands in the same tab to pack the UVs. It's crucial to untick the rotate option in the settings. If you don't, it will disrupt the orientation we just established. Zoom in close to spot any overlapping islands. If there are any overlapping islands, just hit Pack Islands again and increase the margin. If there aren't any, then we're good to go. We're ready to export our low poly mesh. To do this, simply select all the objects in your low poly collection. Then, go to File, Export, and choose FBX link to .fbx. For this step, the default settings will work just fine. Make sure to name the file something descriptive, like low_poly_mesh, or simply low, so it's easy to identify later. This exported FBX file will be what we use for baking and texturing in Substance Painter. It's crucial to ensure that all your UVs are correctly packed and that there are no overlapping islands before exporting, as any errors at this stage will carry over into the texturing process. With the low poly mesh exported, we'll now focus on the high poly version. First, hide the low collection to declutter the viewport. Then, unhide the high collection, ensuring only the high poly meshes are visible. Next, proceed with the FBX export, using the exact same settings we used for the low poly export. Finally, name this file high to maintain consistent naming and easily distinguish it from the low poly version. And that brings us to the end of part 2 of our video game asset creation series. In this section, we covered a lot of ground, from duplicating and simplifying our high poly meshes to create efficient low poly versions, to meticulously unwrapping and packing our UVs for optimal texturing. In part 3, we'll be diving into the exciting world of Substance Painter. We'll cover everything from importing our meshes and baking maps to creating realistic textures and materials, focusing on techniques for achieving those unique surface details we've been preparing for. So stay tuned for the next part, where we'll bring our asset to life with stunning textures. If you found this part helpful, please give it a like and subscribe for more content. Don't forget to leave a comment if you have any questions or suggestions. Crazy signing off, and keep on blending.